will be the same ones that are on it. If a projectile is launched from a platform 8 feet above the ground with initial velocity, blah blah blah. The words are not as important because they have already modeled the function for you. So it's already been modeled for you. They tell you what each variable represents. Now let's look at the question: what is the maximum height in feet that the projectile will reach? What does that word maximum mean? It does mean vertex, but in this particular case, in the way it's being applied, it's the maximum height. Height is taking the place of the y variable, the output variable. So we don't need both coordinates of the vertex, which is the only one we need. Yeah, we need k. H would be, hi Antoine. Good, and you? What is good? What is good? Everything? Okay. I ain't seen him in a minute. Well, don't get this H confused with that H. That's the H of the vertex. Here, but watch. Let's do this. Let's use T so that I don't confuse people. All right. The T is going to tell you how long it takes to reach the maximum height, but it's not going to tell you the maximum height. Negative B over 2A. This does not show up on the reference sheet, so you're going to have to memorize this before you take the final. I'm hoping you have it memorized already. You'll see. That gives you 2. So it's going to take 2. Does it say what time is being measured in? Seconds. It's going to take 2 seconds. But how high will it get after 2 seconds? You need to evaluate it. You can plug in 2 like you would traditionally, or you can just say with synthetic substitution. I feel like we've done this one before. It would reach the maximum height would be 72 feet. On the Google form, what would you type in? What would you type in on the Google form if you're going to do the retake? 72. Caleb, you got all that down? You're not a little worried about where your grades stand right now and where it's going to stand 4 days from now? This equation, which is similar, it's not the same, but it's similar, models the height of a rocket after t seconds. So this one we want to know how many seconds will it take to hit the ground. And it's okay. So it's how many seconds, but it's not how many seconds for the maximum. It's how many seconds it takes to hit the ground. What is the height of a projectile, in this case of a rocket, when it's on the ground? When Caleb dunks and he lands on the ground, how high is he off the ground? Yeah, 0. So you got to put a 0 in for the height. I know we've done these before because I remember mentioning how Anne loves to do these with factoring when possible. And sure, if you're good with numbers and you're not afraid of multiplication and division, and you can see that all of these can be divided by negative 16, it would make your life easier. Minus 5, because it'd be quicker. But if not, you would have to put these numbers in for A, B, and C into quadratic formula. And the quadratic formula at least is on the reference sheet, which you will have on Tuesday. Does anybody want me to do quadratic formula? Well, this is the last day I'll be up here, so if you want to get your money's worth, anybody want me to do quadratic formula? Yeah, you want me? Okay, I'll do that afterwards. So you see we get the same thing. Can you think of 2 numbers that multiply to give you negative 5 and add up to negative 4? Yeah, negative 5 and 1. So we got to make each factor equal to 0, but the 16 doesn't have a variable on it, so you can ignore it. So we really are just saying t minus 5 equals 0, t plus 1 equals 0. And when you solve, you get 5 and you get negative 1. But yeah, these are both solutions. I have not made any mistakes. These are both solutions, but the thing is they're not both valid. Because there's a context here, because these numbers mean something, one of these solutions ends up being extraneous because we're looking for a time. And is it possible to have negative time? No, not if unless you're in the Avengers Endgame. You cannot travel through time. So the only valid response here is 5. So it's going to take you 5 seconds. On the Google formula, put 5 seconds. Now, if you want to do quadratic formula, the reason for doing quadratic formula will be because you just completely want to avoid factoring. So even though those, like, it would be great if I would just tell you, hey, use quadratic formula, but use this as A, B, and C, and it would work. But I would guess somebody that's trying to use quadratic formula is staying away from factoring completely. So it's just not realistic. Somebody that wants to use quadratic formula would probably want to use these. Now there is one adjustment you could make. Anybody have any idea what that would be if you wanted to use quadratic formula right off the bat? If I'm going to use quadratic formula from the beginning instead of factoring, it's not because I want to save time. It's going to take longer, but it's because we want to avoid having to know that all these can be divided by 16. It's just that's a struggle for us, right? But even if we avoid factoring, we could do like a little bit of factoring. There is one little thing, one little tweak you can make to this A, B, and C. You don't have to, and I won't, just to show you that it works. But yes. No, that's factoring. You can make the lead positive. You see how the 16 is negative? That will not work with factoring. If I didn't bring out this negative in factoring wouldn't have worked. For factoring, I need the front to be positive. For quadratic formula, that's not the case. I'm going to leave it negative just to show you a word. For quadratic formula, I can leave it negative, but I still think you're more likely to make a mistake. So you don't need to be an expert with numbers to be able to say, hey, look, I want to use quadratic formula, but I have a negative up here. Let's make the 16 positive. When I go into quadratic formula, make the 16 positive. But if you do that, you have to make the 64 negative, and you have to make the 80 negative. You'd have to change all the signs if you wanted to do it that way. That's up to you. I'm going to leave it as is. So A is negative 16. B was 64, right? And C was 80. Yeah. So then we're looking for T time. So time is equal to, the first time you write B, it's negative B. This is on your reference sheet. What's the name of this part on the inside of the square root on quadratic formula? The discriminant, good. By the way, by now, has everybody had a chance to see their EOC score? Still haven't? Do you ever log into eClassify? It's there. Okay. How many of, let's do it this way, by show of hands, how many of you have logged into the gradebook and seen your EOC score? Like it is visible, meaning that if somebody hasn't seen it, it's either because they haven't logged in or yours came in. So I put it in today. You'll see it tomorrow. Yours came in this morning. Time is equal to negative 64 plus or minus the square root of somebody with a calculator, 64 squared. Be so obliged. 4916. Oh, 4096. How many negatives come after the equal sign? I mean, after the square. 2, so 10 plus 4 times 16 times 80. How many hours? I don't feel like thinking right now. 4 times. I know it's 64 times 80, but I don't know. What is it? 1280? 4 times 16 times 80. 5120. negative. See, this one scares me more than anything is that negative down there. That's why I told you to, if you wanted to adjust it and make the front positive. Because if the A is positive, that stays positive down there. So let's see, negative 64 plus or minus the square root of, what is that? 9, 2, 92, 16. I'm not writing my question. And I'm guessing that's going to be a perfect square. It has to be a perfect square. What's the square root of 92, 16? 96, so plus or minus 96 over negative 32. But now when you go to split negative 64 plus 96 divided by negative 32, you got to make sure you leave that negative on the bottom. T equals negative 64 minus 96 over negative 32. Here I get a positive on the top, but once I divide it by the negative on the bottom, I get negative 1. It's the same negative 1 you saw above. You can't have negative time. But on the other one, what is that? Negative 160 divided by negative 32. There's your 5. So I did it 2 different ways and I got the same solution. Marmy, you writing all this down? I'm gonna do the retake. It's all right. What word can we use to describe this function? It does look exponential. There's an asymptote if you want to be more specific. It doesn't mean it has to be, but it does look like it looks like a growth. It looks like this used to be a growth that had an x-axis reflection. It looks like, I mean, well, there obviously had to have also been a vertical translation down, but the asymptote's at negative 1. But let's see. They don't even ask us about that. All they want to know is if it's increasing or decreasing. If this was Caleb on a roller coaster, okay? Yeah, it might look like he's starting off to go horizontal, but he's actually not. He's very slowly going down, going down, going down, going down. Whee! And he goes all the way down. Did he ever go up at all? Did the roller coaster ever take him up? No. So this graph is always decreasing. It cannot be A or C because it's never increasing. So the question is it only decreasing from negative infinity up to negative 2, which is here, and then it just stops going down, or does it just go down forever? Always going down. We've only studied what's the only type of function that we've studied that changes direction, that has both an increasing and a decreasing interval? Quadratics, parabolas, yes. Agree? Confusion? It's always going down. An investment of $6,000 was placed for 3 years and 4.25 interest, compounded annually. How much more would, and it's even in bold, how much more would be collected if the investment was compounded quarterly? So we're going to have to calculate both. If this was just compounded regularly, annually, the amount after 3 years would be the 6,000 times 1.0425. I would hope by now you know how I got that. Maybe when we first learned it, I wouldn't have just wrote, you know, that that's just the 1 plus the rate to the power of 3 years. And see what that gives you approximately. Because I'm going to give it a calculator. Actually, I'll use my calculator. I'll raise hand. See if we get it first. I win. I got 67, 97, 97. Is that what you got? I'm rounding to the nearest one. 67, 97.97. Yeah. But then now if they did compounded quarterly, what number do we associate with quarterly? Yeah, so in this one we have to start off splitting the rate with the 1, because we have to divide only the rate by 4, but then multiply the 3 times 4, which gives me 12. So 0.0425 divided by 4 equals plus 1 equals 12 equals 6,000. Oh no. I got, 6811.37. So if you subtract those two, what do you get? 168.11.37 minus 6797.97. Is it 114? Wait, no, 13. It's gotta just be this one, right? 1336. That's weird. That's not 1336. What'd you get? What? Oh, because I wrote this wrong. Yeah, this should be 32. No, that's okay. 0.33. So 6811.33 minus 6797.97, and that's 1336. So John bought a rare coin for 4,000. If the value of the artwork increases by 15% annually, what will be the value in dollars of Johann's coin at the end? Oh wow, first it says John and this is Johann. Notice that. Echo. At the end of 5 years, round to the nearest dollar. Okay, this being the key because I left this as pre-response because it clearly says nearest dollar. It's not hard to round to the nearest dollar. That's pretty exact. So the amount after 5 years, if we started with 4,000 and it's annual, so 1.15 to the power of 5. And I'm getting, wow, making some good money. So the nearest dollar, it should be 80.45. And you got the same thing. So it looks like he more than doubled his money in 5 years. There was one that nobody got. I don't know if it might have been this one. Enter the answer in decimal form. For the box plots below, what percent of the girls are below the boys' median? So the first thing I have to do is figure out, well, where is the boys' median? This looks like boys. This is the median. I know it's a little blurry here. I believe that's 4. The boys' median is 4. So they want to know what percent of girls are below 4. So if I go and look at 4 on the girls, it happens to be that the girls, the 4 is actually Q3. So on any box plot, what percent is below Q3? 75. Now if it says enter in decimal form, 0.75. That's what you were asking me about yesterday, Jana? Yeah, that's what decimal form means, 0.75. Did you get that one right? You got that one. Yeah, I think this might have been the one. I think this was the one that nobody got right. You got it right? Okay, then maybe it wasn't. Assuming that C represents a positive number, which pair best represents f of x and g of x? Okay. So the thing is, we start off looking at f of x. Notice what they all have in common. They all have a negative squared, a negative x squared, which is what's causing the parabola to face down. But there's only one more term, and it doesn't have an x in it. In this case, x is the only variable. And I'm guessing they use c for a purpose. What do you think c stands for? Well, it stands for constant, and yes, the constant is the y-intercept. So assuming c represents a positive number, which, well, it is, you could tell because look at where this is crossing the y-axis. It's above zero. Which pair would best represent? Now, actually, you know what? No, I still stand there. That's fine. This is perfectly sound. The key is to focus on the next one, g of x. Is that crossing the x-axis above it or below it? Yeah, below. How far below? Well, it looks to be about halfway below. So what would be the best one? It can't be negative because if it was negative and c was positive, right? Then a negative positive is a negative. This would actually cause it to cross down here. So like the only ones it could be are A and D, but this negative being in front would cause it to flip over to the other side and face down. It would actually look something like this. So, at 7 a.m., there are 2 people in Miss Thomas's room. Every 30 minutes, 4 new people enter. For which sequence does the nth term represent the number of people n hours after 7 a.m.? So here's the key here, though. Every new n is a new hour. But they tell us that we're getting 4 new people every 30 minutes. So if you get 4 new people every 30 minutes, how many new people are there every hour? Yeah, it's 8. The common difference should not be 4, it should be 8. So which one here? The 2 people every, yeah. So and like see the thing is, at 7 a.m. when there was 2 people in there, how much time had passed by? Yeah, no time had passed by. We're here. We're talking about n hours. So we assume that the first number we see is what's happened after the first hour. Like 1 hour has to have gone by. If that's what the n represents, is hours. There's 0 hours. There's no, like, unless you're told otherwise, we assume the first number we see has an n value of 1, and 1 is hours. So which one of these has us starting? Well, 2 people plus 8 is how many? 10. So it can only be then either B or D. Now, conveniently, even if you got that far, the other thing that was meant to trip you up is if you look at D, it's going up plus 4. But we don't want to go up plus 4. We want to go up plus 8. So B is the answer. Select all that apply. These functions are defined below. Which statement is true about these functions? Okay, f of x increases exponentially. Is f of x this first one? Is it an exponential function? Yes, bam, check. G of x increases linearly. Is g of x a linear function? Yes, it is. Bam, B works. H of x, does that increase exponentially? No. What type of function is h of x? It's quadratic, so no dice. F of x, okay, watch. If you remember when we did that unit on comparing functions, when we talk about very large values, that we're talking about what's happening as we go to infinity. As you go to positive infinity, which of those functions tends to get biggest the fastest? Exponentials. Yeah. What gets biggest the second fastest? Quadratics, and then the slowest ones are the linear. So f of x is greater than h of x for very large values. F of x is exponential, g of x was linear, so yeah, it is f of x is greater, so D is going to work. F of x and h of x are similar in value for very large values of x. No, h of x, no, they might hang close for a while, but once you start going further and further to positive infinity, this is going to blow it out of the water. If I make x just like I said, 1,000 squared is going to be a lot bigger than 15 times 1,000. And the further and further you go, it's going to get even bigger. So, no. There is no value for x so that f of x is equal to g of x. That would have been the hardest one to answer, I guess, for you guys. Okay. Now, what I would have done is I would have tried to visualize a graph. I think you're not going to be able to solve that. You do not have the tools in your possession to be able to say 2 to the x is equal to 15x plus 4 and then know how to solve. It's not going to happen. But here's what I would do. If you visualize a graph, you should know what type of exponential function is f of x. It's a growth with an asymptote at 0. It would look like that, right? 15x plus 4 is a linear function with a positive slope that's crossing at 4. It's probably going to cross somewhere up here with a slope this way. They may not cross up here. We don't know. We don't have a graphing calculator. This is gonna, and actually they probably will, because this is gonna flatten out. This is gonna get a lot steeper. So actually, yeah, you know what? They probably will cross somewhere up here. But even if they don't, we can tell for sure, because this is just laying flat, waiting to get crossed, that it's gonna cross there. And when you say that two things are equal, two functions are equal, you're asking is, do they have an intersection? So they definitely have one intersection. They probably have two. So that can't be true, because it says that there is no value. No, there is a value. Luckily, they're not asking me for what it is, because then I would need to know how to solve this. But luckily, I don't have to know. Any questions there? Speaking of intersections, here we have an exponential, a quadratic, and a linear function, and they want to know which would have the greatest value for real. Oh man, I cut it off. I think you saw the whole thing. You saw the whole thing. It said, I think you probably said really large. It said really large. So what gets the biggest on large values? Exponentials, quadratics, or linear? Exponential. Which one is the exponential one here? It looks like h. H is the exponential. Miriam threw a rock at a tree that was 400 feet away. The number of seconds and the number of feet that the rock traveled are shown below. What is the function that represents the distance that the rock traveled in feet? All of these are linear, because this is just multiplying times t. So linear means that there should be a common difference. In order to be a common difference, these have to be going up by the same amount, which they are. And it looks like the common difference is 37, but the thing is, you can't just put the 37, because the thing is the second is not going up by 1. So you have to, probably the easiest thing for you to do here is just use flow formula. The nice thing is one of the points you can use is 0, 0. And then the other one, let's just use 1.0 and 185. So 0 minus 185 over 0 minus 1 is negative 185 over negative 1, which is 185. Another way you can look at it, if you want to look at common difference, fine, look at common difference. But don't look at 0 to 37, look from 0 to where it becomes 1. For every 1 unit that x goes up, y is going up 185. Stop me if you're stuck on something. A patient takes 500 milligrams of amoxicillin, a common antibiotic. Every hour, the concentration of amoxicillin in the bloodstream halves. So this is a half-life problem. Which of the following sequences expresses the amount of amoxicillin in the bloodstream n hours later? So these look to be recursive definitions. All of them start off. Okay, well, all of them start off at 250 because after 1 hour, then when that 500 gets cut in half, how much is left? 250. Then which one of these says that every new hour will be the same as the hour that came before it? So meaning like every new plus every hour plus one is going to be half of the one that came before it. Yeah, B. But this is an exponent. It's not to the 1/2 power. I might have just dragged this. Is this the next one on your paper? The parent function of all base 10 exponential models is blank, okay? Then they give you a new function, blah, blah, blah. And they just want, okay, so this is just a transformation problem. Let's identify A, H, and K. What number's in the A position of this function over here? What number's in the A position? 2. What's in the H position? Negative 12. Okay, it's this plus 12, but you gotta change the sign. A is negative 37. So which one here has a stretch of 2, a translation left 12, and a translation down 37? Okay. A radioactive substance decays at a rate of 45% per day. The original amount of the substance was 32 grams. The graph below, well, there's no graph below, shows the amount of substance left after X days, which equation shows the amount of the substance remaining after X days. So we want to see the thing. We want to know how much was remaining. We don't want to know how much is decaying, how much we're losing. We're losing 45%. If you lose 45%, how much are you keeping? Yeah, 55%. And if we started with 32, are you drawing a gargoyle? Does it have large talons? Miss Reeves has split her classroom into 3 groups and asked each of them to make predictions on the population growth of classroom frogs. The table below shows 3 group models where each function predicts the number after X generations. Okay, so these are the same thing about large values, where when we get big enough, exponentials get biggest the fastest, then quadratic, and then linear. So look at the first one, f of x, that's going up by 3, so this one's linear. G of x, it looks like it's doing times 3. That would be exponential, sure. And then this next one you might not be able to tell, but we actually learned it. I don't know if we did it towards the end of the first. I don't think any other algebra one teacher does this, but we learned about the second difference. Remember we learned about second difference? So if you take, not that you had to, I mean, you could have done process of elimination, but if you do 3, 6, 11, 18, and 27, if you take the first difference thinking that it's linear, you would get, so this is plus 3, plus 5, plus 7, plus 9. But then when you take a second difference, that becomes common. When you have a common second difference, that's when it's quadratic. So this confirms it's quadratic. So what's going to get fastest, the biggest? Well, actually, no, wait. These are less than signs. Which is going to be the slowest? The slowest is the linear, which is f of x. Then we would go to, what is that, r? R to R of X and then G of X. That might have been something they're showing you in the might have gotten away with a little margin. That showed up on the test. See what I'm talking about? Devin compares two investment plans. He has $1,800 to invest and has the following options. Plan A is a chart. Plan B will add $150 a year to his account. Which of the following is true? Plan A is the best option if Devin plans to withdraw the money in 10 years. Okay. Well, here, let's see. If we're adding 150 to an account each year, is that what type of model would that be? Linear. So then the y would be equal to 150x, and we started with what's that? With 1800. Sorry. So in 10 years, it would be, you're getting this 10 and plugging it in for x. That's 1500 plus 1800 is 3200. I'm doing that in my head. So this plan here gives you 3200 after 10 years. This gives you 2932. So plan A is the best option for that? No, that doesn't appear to be the case. Okay. Let's look at plan A is the best option if he's going to do 25 years. In 25 years, he gets 6095 there. With this one, somebody help me with the math here. What is 150 times 25 plus 1800? 5. What comes next? So, and yeah, that does appear to be true. That plan A is the best option in 25 years. But with these, I always like to check them all because if I end up getting two that are correct, then I have to go look at it closer to see if I'm doing something wrong. Plan B is the best option regardless of how long he holds the money. No, we just showed you a counter example of that. Plan A is better for 25 years according to our calculations so far. Plan B is the best option if Devin intends to hold the money in 40 years. Well, that doesn't appear to be the case because it looks like they just had a cross. Before Plan A was worse, now Plan A is better. That doesn't appear to be the case, but let's double check. If you plug in a 40, it's going to give you is it $7,800 that would give you in 40 years? And well, this one here doesn't tell me what's going to happen in 40 years. You'd have to find I guess the function, like what is the formula for that function, and plug it in. But it doesn't. If at 50 years you're going to get 20,000, Plan A should be better. Any questions there? Last one, a farmer determined that the total cost in dollars of selling strawberries at a local farmer's market can be modeled by this function where X is the pound of strawberries that he brings to the market. Which statement is true? All right, so f of X is the total cost. Like, this is how much it's going to cost him to sell strawberries. And X is the pounds of strawberries. So the farmer's market total cost of attending the farmer's market and selling his strawberries is $45. Well, that makes sense because when he shows up to the farmer's market, how many strawberries has he sold? When you first show up, how many strawberries have you sold? None. So if he sells 0 strawberries, then his cost there is just the $45. Total cost of attending the farmer's market and selling strawberries. Well, actually, no. That doesn't make sense yet. Because total cost of selling strawberries. No, because it looks like the farmer's market is going to charge him 9 cents per pound. Um, yeah, it didn't say initial cost. It says total cost. So actually, I don't like A so far. Let's look at B. The farmer's total cost of attending the farmer's market and selling strawberries is $90. Well, no, nowhere does it suggest that. For each additional pound of strawberries that the farmer brings to the market, the cost increased by 45 cents. No, that doesn't make sense because that's not what you're multiplying the x by. You're multiplying by 0.9. So the answer here looks like B. For every new pound that they bring, the cost increased by 90. 0.9 times 1 is 90. That's going to be B. You didn't go to lunch? You didn't want to go to lunch? Why didn't you go? No, I told you you could go. I told you to go to the second half. Huh? Let me check now.